All right. My nephew asked for a explanation of how atoms stay together, and I wanted to just go ahead and record this, and I can leave it open for other people if they're curious about it too. When we talk about atoms sticking together in bonds, there's really two that we would be interested in. One are what we call ionic bonds, and the other one are covalent and metallic. Now, the ionic ones are actually relatively easy to understand because in these circumstances you have atoms that are going to be different types, and they are going to have associated charges with them. So sodium chloride is a really good example of this. What happens is the atoms will exchange electrons because it's more energetically favorable for them to do that. And then at that point, what you have are a bunch of things that are opposite charges, and so they get attracted towards each other. And what holds this together is simply just electrostatics. That's one reason why a lot of these types of materials tend to dissolve relatively easy in things like water, because the water molecule can kind of get in between them and make it harder for them to get attracted to each other. Now, for covalent and metallic bonds, it's a little bit more tricky. So if I wanted to imagine that I have two atoms, and so these are the nuclei for the atoms, and then I'm going to use the green kind of to highlight the electron clouds around them. If we were to look at the an individual atom here, the thing we would find is that there is the positive that's here in the nucleus, and then there's this cloud of electrons around it. But outside of this area, it's going to be neutral. So anything outside of that region is going to just see no charge, because the nuclear charge and the electron cloud actually cancel each other out. Now, if we imagine that these atoms get closer together, and now just to help distinguish this, I'm going to use two different colors for the clouds of the electrons. And so what you can see is that we have an area where there is an overlap. Now, atoms not being a solid object, though don't let anyone tell you about this nonsense about them being empty space, but they are not solid objects, and so because of that, that means that you can have two atoms that can kind of mush into each other. Now, there's an important thing that happens when this is the case, though, and that is that this boundary that I drew before that showed where the atom appears to be charge neutral, well, this other atom is inside that a little bit. And so the consequence of this is that we end up with something where this atom, I'll just call it atom B, is seeing a circumstance where it's no longer seeing a charge neutral. It kind of matters that this stuff that's inside of this region here is going to actually see the electrons in this atom B are now not being other ones. So Screening is this process in an atom where the cloud of electrons is going to block out the positive charge of the nucleus. When another atom starts getting closer to it, effectively you have, like if we want to zoom in on this area here, we might say that, okay, we have an electron from atom B. We also have an electron from this atom A. But the nucleus for atom A is actually closer to electron B from the atom B. So that's going to actually get a attraction to it. And so the consequence then is that as the two atoms get closer together, the electrons from one atom get attracted to the nucleus of the other. And so that produces this force that basically makes the two atoms get attracted to each other. Now, if you're asking, well, what does that mean? Because doesn't that suggest that the two atoms should completely merge into one atom? The answer is no, because there's also a repulsive force that goes on. Part of it is simply from the two nuclei, because as those nuclei are getting closer to each other, they're also having less screening, and so they're getting pushed away from each other because they're concentrated points of charge. So if you were to look at like how much attractive force versus repulsive force you have as a function of the distance between the atoms, you have two things going on. First off, you have this thing where it becomes more attractive, so a negative force would mean that they're getting closer together. But you also have this repulsive force that shows up from the nucleus and also the mutual clouds of electrons pushing away from each other. So in the end, you have something where we combine those two forces together and you have something that looks like this. And you'll notice that there is one particular distance where those two forces sort of balance each other out, or it's the most attracted that the atoms could be to each other. So that's actually what brings about the atomic bond length. And so basically then what's going on is one atom gets so close to another that some of its electrons are actually closer to the nucleus of the other atom than the other way around, and that causes it to get attracted. But what stops it from just completely going together is the fact that you are still mushing two clouds of electrons together, and there's a number of factors in there that prevent that from happening, and the two nuclei getting closer to each other are going to start pushing away from each other. And that force just simply gets much stronger than the attractive force at the end. So I hope that actually helps with that. Screened by the